In the last few videos, we were taking a look at a two-pointer approach, which is a way of iterating an array in two different ways at the same time, say iterating it both forwards and backwards was something that we saw fairly commonly. In this video, I'm going to show you another type of iteration that's commonly used, known as a sliding window iteration. A sliding window iteration really works best for cases where we want to work with a subset of data inside of an array. In these sorts of cases, we can actually define what we would call a window, which is a set of data that is inside of our array, and we could do something with that set of data. And then if we need to, we can move that set of data throughout the array. So we can move that window to work with other sets of data inside of our array. And the first way that I'm going to introduce this idea is using a problem known as best time to buy and sell a stock. And in this problem, what we're given is we're given an input, which is an array of prices for a stock. And as an output, what we want to find is we want to find the maximum profit we can make from buying and selling the stock. So let me give you an example of this to help sort of formalize this idea. So maybe we have an array of values like this. Each of these values represents the price of a stock on a given day. We can buy on one day and then sell on another day, and the difference between those two prices would give us our profit. So for example, if I were to buy at 7 and sell at 5, I would lose $2, right? Since 7 is a higher price than 5, we would have negative $2 as a result. And our goal is to try to maximize the profit, which basically means we want to find the price that we can buy at, and then the subsequent price that we can sell at, such that we have the highest possible profit. In this example here, the highest possible profit would be 1 and 6. In this case, we would buy at 1 and we would sell at 6, which would give us a profit of 5. So my question to you is, how can we approach solving this problem? What we're generally going to do is we're going to use this idea of a sliding window. And the window that we're going to be working with is going to represent the buy and sell point of our stock. So for this particular example here, we might start with the value 7. We might say, okay, what happens if we buy at 7? And we can analyze it against the next value. We could say, if we buy at 7 and sell at 1, well, we'd have negative 6 in profit. But what we notice here is we say, well, 1 is smaller than 7, so maybe we could buy at 1 instead. And then we repeat that process. So we say, well, 1 and 5 would give us a profit of 4. So that's a better profit. So the profit is now 4. That's the maximum that we found. And we look and we say, well, 5 isn't smaller than 1, so we'll continue to buy at 1. And then we'll try selling at 3. What does that give us? It gives us 2. That's not better than the previous one that we had. So we'll check again and we'll say, well, maybe 1 and 6, which gives us 5. And we see that that is higher, so that becomes our new maximum profit. We just keep repeating this process, updating the left-hand side to be our new buy price when we see something smaller, and we will eventually end up with our maximum profit. Do you see how this basically creates like a window of data, right? We have like the smaller subset that represents the buying and selling point, and all we're really doing is just updating our buying point each time we see something smaller, and we update our profit each time that we do better from our buy and sell prices. And that's the general process that we're going to go through. The actual code for this is actually pretty easy, right? So the idea is that we could take in our prices, and what we do is we say, we'll start by assuming that our buy price, the price that we're going to buy at, is the value at index 0. And then what we do is we assume that our profit, our max profit is 0, right? So the max profit that we can make is 0, and then what we'll do is we'll just iterate through our array of prices. And, we can iterate just through the whole prices, or we can iterate from starting at index 1, since we've already taken a look at index 0, so we don't really need to look at it twice, right? And basically all we're really going to do here is we're going to say, well, if the value p that we're currently at is less than our buy price, then we just make the buy price equal to p. So this is basically saying if the value that we're currently at is smaller than the thing that we're currently buying at, we're going to choose to buy at that value. And then from here, all we do is each time we just recalculate our profit. So our profit is going to be the maximum of our current profit value and then p minus the buy price. If p minus the buy price is bigger than our profit, then we update our profit. Otherwise, we keep the profit as our maximum profit, right? And that's really all there is to it, right? From here, we return back our profit and we are done. Nice and easy, right? So let me show you what that ends up looking like with an example. So I'll do the max profit, and I'll do it with this exact array right here that I put in. And we'll go ahead and run this, and we'll take a look at what we get. So we'll do stock.py, and you see I get the value 5, which would be at 1 and 6, right? Which gives us the value of 5. as a result. So you can see that this does actually look to give us the proper result. Now the question here is, what is the time complexity of this? The time complexity for this is pretty straightforward, right? When we take a look, max is a constant time operation. We don't have to worry much about this. All these different operations are all constant time, so really the loop is the main piece that we're worried about here. For this, what we do is we iterate through the whole array, but technically the whole array minus one value, but we could generally just say we iterate O of n times, right? So we iterate O of n times, where n is the size of the actual array that we get as an input. This is a pretty good solution to this problem. I think that this is probably one of the main optimal solutions that we would have for this sort of problem. So that gives you an example of our sliding window approach. So with that, you do see a bit more about how that sliding window approach generally is going to work for problems that involve a subset of data. In this case, the subset was a buy and sell price inside of an array of stock values. So thanks so much for watching this video, and I'll see you in the next one.